Okay, today we're going to talk about optimization with calculus. And so in our assignment, we're given the task of finding the optimized size of a box container. And this box container is going to be made out of an 8 by 15 sheet of cardboard. And then we're asked to find the maximum volume that we can get by cutting corners out of the edge. So the first thing I want to do is draw a picture. So I've got 8 by 15. That's what we start with. And then we're going to cut congruent corners that are perfectly square out of each corner and then fold the sides up. And so to draw my picture accurately, what I'm going to do is I'm going to need to draw 4 congruent corners, and they don't have to be to scale because after all I don't know how big they need to be. But one thing that I know is that the corners are going to be x times x. Alright, and so now to find the volume of this box and to optimize it, I need to start with the formula for volume. So to find the maximum volume, I guess is what we're trying to find, the first thing I need to do is start with the formula that would actually calculate the volume based on how I take this approach. So I want to write this in terms of x, and remember that it's going to be length times width times height. So for the length, the total length for one side would be 8 minus 2x. So I don't know how long x would be, but I would subtract x twice, and that's what I would have left. Then the width would be 15 minus 2x, and then the height of the box would actually be x. Now to find the maximum volume of this, what I need to do is take the derivative of that. And so to help me take the derivative of that, I'm going to FOIL these binomials through, and I should get a cubic. So just over here where I've got a little empty space, I'm going to multiply 8 minus 2x times the quantity 15 minus 2x. And I'm going to write it in here, and it's going to be kind of small, but I don't have a lot of room. And when I'm all done, what I end up with is 4x squared, and then when I combine like terms, negative 30x plus 120, but when I push that extra x through, I end up with 4x cubed, and I said 46x squared. So let me erase this real quick. So I end up with 4x cubed minus 46x squared plus 120x. And so that's my equation, and then I need to take the prime of that. And let me scribble that out so you guys don't get confused. So the original volume equation is 4x cubed minus 40x squared plus 120x. And by using the power rule, the derivative then becomes 12x squared minus 98x to the first power plus 120. Or 92, I'm sorry. It's hard to talk and write at the same time. So anyway, so this is my derivative of the function. Now remember, in order to solve the derivative of the function, we're going to set it equal to 0. Therefore, I'm going to need to factor this derivative. So the first thing I'm going to do is I'm going to reduce it a little bit. It'll make it easier for me. I think everything is divisible by, let's try 4. So if I divide everything by 4, I get 3x squared minus 23x minus 30. And 23 is a prime number, so I can't factor it any lower. So now I need to factor 3x squared minus 23x plus 30. So I'm going to take the grid over here, and I'm going to start with the first and last term and kind of guess and check. So I've got 3x squared and 30. Well, 3 is a prime number, so one of these has to be 3x and the other one has to be 1x. And I've got a negative number in the middle, so both these terms are going to have to be negative because that's what makes my last term positive. Now I've got to guess and check. 3 and 10, 2 and 15, or 5 and 6 are the factors of 30. And I just have to figure out which combination of those will give me that middle term of negative 23x. So let me think here. I think it's 5 and 6, but now I've got to think where to put the 5 and where to put the 6. If I put the 5 here and the 6 here, I think it'll work because that'll give me negative 18x there. and that gives me negative 5. Yep, if you add negative 18 and negative 5, that's 23x. So basically what I've done is I factored 3x squared minus 23x plus 30, which is a product of 3x minus 5 times the quantity x minus 6. So now I just set both those equal to 0, okay? And then that'll give me the zeros, and that's where the minimum or maximum values occur. So if I set both those equal to 0, I end up with x equals 6 or x equals 5 over 3, I think. So now I got to go and see if one of those solutions is extraneous. If I let x equals 0 or x equals 6,